Here's a muscle cell. Here's some blood sugar outside, waiting patiently to come in. Insulin is the key that unlocks the door to let sugar in our blood enter the muscle cell. When insulin attaches to the insulin receptor, it activates an enzyme, which activates another enzyme, which activates two more enzymes, which finally activates glucose transport, which acts as a gateway for glucose to enter the cell. So insulin is the key that unlocks the door into our muscle cells. What if there was no insulin, though? Well, blood sugar would be stuck out in the bloodstream, banging on the door to our muscles, and not be able to get inside, and so with nowhere to go, sugar levels would rise and rise. That's what happens in type 1 diabetes. The cells in the pancreas that make insulin get destroyed, and without insulin, sugar in the blood can't get out of the blood into the muscles, and blood sugar rises. But there's a second way we could end up with high blood sugar. What if there's enough insulin, but the insulin doesn't work? The key is there, but something's gummed up the lock. This is called insulin resistance. Our muscle cells become resistant to the effect of insulin. What's gumming up the door locks in our muscle cells, preventing insulin from letting sugar in? Fat. What's called intramyocellular lipid, fat inside our muscle cells. Fat in the bloodstream can build up inside the muscle cell, creating toxic fatty breakdown products and free radicals that can block the signaling pathway process. So no matter how much insulin we have out in our blood, it's not able to open the glucose gates, and blood sugar levels build up in the blood.